Hello guys, today we're going to be covering data structures with Python. So the type of data structures we're going to cover is lists, dictionaries, and tuples, and also sets, which you won't really be using that much. So let's start. So the first data structure we'll be covering are lists. So let me show an example to you. Let's create a variable called mylist. Create a list of it. 7, 6, 5, 4, 3, 2, 1. Now, so data structures usually can hold more than one object. So lists here are they're very easy sort of things. So lists go around these square brackets, and then the values are given in. So let's run this. Now let's print out my list. Yeah. So the my list holds the object 7, 6, 5, 4, 3, 2, 1. And you see these square brackets. So let's just try to print it instead. It does the exact same effect. Okay, so anyway, so it's the exact same with the list function. So the list function turns an object into a list. So it's the exact same here. Now, what if we want to add something to a list? Like, let's say my list. So let's say that you want to add something after this 1, let's say, and you want to add 0. Then that's pretty easy. All you have to say is call back my list dot tab. Oopsie. So if you say tab, then you get this bunch of options. So to add something at anywhere you want, you have to say the append, and then you give in the object that you want to append. So then if you look back at my list, you get back 2, 2, 2, 2, 2 at the end. Now, what if you want to add something at let's say here? That's pretty simple. All you have to do then is, let's say index number 0. Oopsie, I mean, not like that. Oopsie, my bad. So the way you have to do is tab, append, let's say 2, 2, 2, 2, index number 0. Okay guys, so you can only add something at the end, or you might have to rename it. So for now, we just add something at my list. Oopsie. And so it's like that. And you get these bunch of tutus because I've actually run this 3 times. Okay. So anyway, now what if you want to remove an object at the list? Now, to remove, we may use the remove or the pop. The pop we use the pop method. So we put in, let's say -1. So you can put in the index number which you want to pop out. So let's say index number 0. Now 7 is popped out. It shows the number you're popping out. Okay, okay guys, so you can also and you can also rename an index value. Let's say you want the 0, which is here, the 0 index position to be renamed to E. So when we look back at my list, this is back into E. So my list is mutable, which means that objects can be changed within it. You might have seen that already here. So now let's talk about dictionaries. That is the second next thing which you'll be using more often. So, in dictionaries, the way to create a dictionary is, so first of all, what is a dictionary? A dictionary is a data structure that can hold in items that have a value and a key. So let me show you how that is. So let's say that my deck, or rather that my deck equal to, and remember, dictionaries come around these curly braces, or rather curly brackets. And then you can put in like whatever keys you want. And this is something that you might have always wanted. You can also put in numbers as the key. So yeah, I think dictionary is like as if it's multiple variables in a variable. Yeah, that can only be found in that variable. I feel like that. So now you can assign the dictionary like this with the colon. And then you assign its value. Let's say this value to be true. And remember, if you're assigning a string, that is the only difference. Because when you're assigning string, like let's say a character as a variable, since the h is anyway a character, you still got to put the strings. Now, let's assign this to false. Oh yeah, oopsie. I thought of like a variable. Okay, so when we see my dict, we get the objects. And the same with the dict function. Yeah, because a dict just returns a dictionary of any object. And remember, the dict only works for that. So one way you can use the dict function is, let's say, h equal to hd, and that f, 9 equal to false. Oopsie. Okay, so yeah, so you can't exactly use the dict, but for that, but the dict function can still be used to put in like some sort of dictionaries. I mean, you don't really use it unless it actually comes in use cases. So next, so the methods for my dict is we just put a dot and tap. Here it comes. Now, what you can do with the dict is, what if you want to add an item? Okay, so you can get the items. Oopsie. So dict item 6. So with this items method, what you get is, you just get this variable name, which is here. And then you get this curly brackets. I mean, just brackets. And then you get the square brackets. And then you get some like brackets, normal ones. And then the objects are passed in with the brackets. And then the value comes last, and the key comes first. Yeah. So you don't really have to use that mydict.items function, but it might become useful if you want sometimes. So now, let's say you want to like add something. So to add something, what you may do is, so you can't exactly add some dictionary. Okay, but you could change the values. So let's say, okay, so the way you do like index values with dictionaries is, let's say that you want to like get in the first item. Well, you might have put in 0, thinking that is a proper index like syntax. But When it comes to dictionaries, it's actually pretty different. Instead, you put in the key name. And then it becomes true since you passed in that. And if you type if you put in hedge, you get false. And what if you want to okay, yeah. So now let's talk about a complex or dictionary. Let's create a few cells here. Okay. So let's create a dictionary called dict. I mean, we're not really going to be using the function. So dict equal to, rather, let's say, let's just say hedge for now. Or for D for dictionary, anyway. So let's create a dictionary of scores. Or do I rather mean names? And with a list with the value. Yeah, so the value is a list of objects. Let's say, now let's talk about scores, let's say, and that is also a list. Okay, so the names, let's put in names as 6, 5, 4, 3, 2. Now, since this is a list, when you come after this can be represented as index, but not the key or anything. Anyway, so the scores is, so the names, let's just rename them to proper. Bob, Sam, and then let's say 3. And then let's say then let's say Tom. And then maybe we don't really have to add one because I'm out of names in my hand. Okay, so let's put that Tom has 70%, 70 score. Or let's say just A plus. A and Sam A. And let's just say a C plus. Okay, I know those are just some sort of olden times way of scoring. Anyway, so let's call back D. It just brings back the exact same item of the whole dictionary. But what happens now is, if we put in names, instead it brings out a list of objects. And let's say you want to bring out 3. And since this is a list, you have to use the normal index values. Let's say 1, and that brings out 3. And let's say 2, and that brings out Sam. And 3, and 0, Tom. Okay, so that is one way. And you can make even further from this list. So what you can do with this list is, you can even assign list. You can assign dictionaries inside dictionaries. So what I mean is, let's say of adding another value here. Let's say, and then let's say more equal to none. And then if we put in 4, it becomes more or none. And since this is a dictionary, we can just get back more. So see how long dictionaries can go? It can go as far as you like. So it can become even specific, even specific, even specific. So it can become as specific as you like. So that is one good thing about dictionaries. Now, let's talk about tuples. Yeah? I mean, this might seem actually a little bit useless to you, but anyway, I'm telling it still is an important data structure. So, tuples are like, you know, so I'll just call them tup for short of tuple. So for real, tuples can go like this. So the tuple function is like, can go around in like, so I'll just like put in my list in this. And you get back a tuple. So instead of square brackets, you get back the normal brackets. So what is the speciality of a tuple? The speciality of a tuple is you cannot change the object without reassigning it. Like let's say a tuple here. And tuples go around these brackets as I told you. Let's give a list of objects. Let's say apple. And let's say orange. Oopsie. Banana. And let's just give like, let's say cherry. If we get hatched, then we see out this huge list. So, if you see here, apples and oranges and banana cannot be changed unless they're reassigned. So if we say like hatch 0 equal to like let's say 9 or 0 rather, it says type error. Tuple object does not support item assignment. So what does this mean? So it means that it does not support this assignment. So the only way to change it is by reassigning the whole thing. Like 0, let's say 1, 2, and 3. Now this is the only way that you can change a tuple. Or else if you do it like this, it'll say tuple object does not support item assignment. Now, you must be wondering, then what is the use of tuples? Well, one use of tuples is, what if you don't want to change an object and you might have done it accidentally? Well, that's where tuples come in. Because once you figured out that you cannot change an object, then you won't do it, since the error will come up. Like let's say by blah 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 something in some sort of job or something, that you first found this as apple, and then it shouldn't be changed from apple. But if you accidentally change it to, let's say, another fruit, like let's say mango, then you'll figure it out because it says this type error. Anyway, so that is the use of tuples. And there are some two methods for tuples. One is the count method. The count method like counts in what index an object is there. Like let's say, in what object is the first banana there? Like let's say, and then we type in the thingy. Then it comes at 0 for some reason, though. So it actually though basically counts how many of the bananas or whatever it is there. For some reason it's not working. Anyway, so if I reassign this, yeah, now it works. Well, if you use the index method, then it'll count on what index the banana is. So that is lists. Now let's talk about sets, the last topic in today's video. So sets are like a collection of objects that should not be more than one of the same object. Like what I mean is, in like in my list, we accidentally added more than one of the 2 to 2 thing. Remember? Well, sets does not add this thing. It cannot add one more of the same object. Well, it doesn't put in an error, but except it just ignores the code that adds more than one object. So, yeah. And remember, and one more piece of information. Sets are actually like unordered. If you're in a small set, then it might be ordered. But if it's a large set, then it might not be an ordered. Okay, so let's create a set. So sets have to be created like this. Instead, you use the set method, or rather you have to use like curly brackets. But instead of adding like key and values, instead you just add random values itself. Like let's say 1, 2, 3. Now if you print out S, you can get it in ordered, right? But if you add more, then look what happens. Okay. 6, 7. Then it might be ordered if it is like medium or anything. It has to be like a really long list. Then let's say see that now it is unordered. So remember one thing. Sets are unordered series. Okay, so let's say like set S. So the set method is also a method. So for real, we won't really be using these methods. But if you use the set of my list, you'll figure out that even the 2 to 2 is repeated only once, and that these values are also unordered. Did you see that? So sets can work on any values other than dictionaries. Okay, so you won't really be using sets. So anyway, so that's it about data structures for today's videos. So bye bye guys, see you next time. Bye bye guys.